Okay, let's do this next example of finding the zeros of a polynomial function. We've got a fourth degree polynomial, so it's going to have 4 zeros when we count them individually. I'm going to begin by looking at the sign changes in f, and there is only one. Okay, so that means that this function is going to have one positive real zero, and then we're going to look at the sign changes in f of negative x. So that gives me this function here that I'm writing. Okay, and so let's look at the sign changes in f of negative x. There's 1, there's 2, and 3. Okay, so that means that f of x, the original function, could have 3 negative real zeros, or it will be less than that blue number by an even. So 3 minus 2 is 1. Okay, so there's going to be 2 possible outcomes for this function. One positive real zero with 3 negative real zeros, or one positive with 1 negative real. Okay, and we can summarize that with a little chart, and it's going to have only 2 rows. Okay, so you're talking about positive real, negative real, and then non-real. Okay, so non-real allows and includes the numbers that have i's in them, right? So we've got 1 and 1. So that 1 in red will pair up with the 3 in blue, or the 1 in red will pair up with the 1 in blue. Okay? Now remember that this is a 4th degree polynomial, so that each row has to add up to 4. So if you've got 1 positive and 3 negatives, you're not going to have any more zeros, so you can't have any non-reals. And then here you've accounted for only 2 of them total, so the other 2 have to be non-real. Okay. Now, finding the list of possible rational zeros, I'm going to take my factors of negative 24, that'll give me the p's. And then I've got my q's, which are just plus and minus 1s. So all of the p's divided by all the q's will just give me back the p's, right? So I'm going to have a negative 24, negative 12, negative 8, negative 6, negative 4, okay? And then the positives. Another marker there, it's fading. Okay, now we need to check to see which zeros from this list. That's a long list of numbers that could potentially be zeros of f of x. Now we're going to choose from this list and try to use Descartes' rule of signs to guide us. So no matter what the outcome 1 or outcome 2, you are guaranteed to have at least 1 positive real zero. So we could start with the positive numbers here. Then as soon as we find it, hoping that it's on this list, as soon as we find it, we can then throw away all the others. Okay, so why don't we start with 1? Okay, so I have to put in the coefficients for f. And now perform synthetic division. Oops, that's a 9. I'm adding vertically, right? Yeah. So now that gives me 26. Multiply diagonally, I get 24. And that worked out nicely. Okay, so now we have found that f of 1 equals 0. So 1 is a 0. Okay. and it could potentially be a repeated 0, okay, when you're doing the homework. So I would then check to see if 1 is a 0 of this next polynomial. Okay. Now, using the factor theorem, I know that x minus 1 is a factor, and then the other factor would be this third degree polynomial here. Okay. And I mentioned to you that when you're doing the homework, you'll want to check to see if 1 is a 0 of this third degree polynomial. Okay. And I already know that it is not. Okay. Now, we also want to see if this third degree polynomial is factorable by grouping, and it is not. So now we're going to be able to throw away all of these other possibilities here, okay? Because we've already found the one positive real number that works, and it's 1. So now we can jump to the negatives. Okay, so I'm going to now perform synthetic division with -1. And I'm going to do it with this third degree polynomial here. Because our goal is to try to factor f of x down into lower degree factors. Okay? And we see that that doesn't work, right? So f of -1 does not equal 0. Oops, that's not, is that right? 26 minus 8. That's not right. That's 18. But regardless, it's still not 0. Okay? 26 minus 8. Okay, so we are done with -1. And now we're going to try -2. So let's do that right here. So bring down the 1, multiply diagonally, add vertically. And that gives me 12. And yay, I found my next 0. Okay. So we now see that f of -2 equals 0, and we have found another 0 of f. All right, now let me do a little bit of erasing here because I'm running out of room. So you can rewind on the videotape to see these numbers. And I know that this problem is almost done. Okay? We know that f of x had already been factored into x minus 1 and then this third degree polynomial. But now we just found the -2, which is a 0 of that third degree polynomial. So that means that I know that I have a factor, which is x plus 2. And then the other factor is going to be this second degree polynomial. So it's an x squared plus 7x plus 12. And now we can factor that second degree polynomial. Good old-fashioned factoring. What are the factors of a 12 that'll add up to 7? Well, 4 and 3, and they're both positive. Okay? And then setting the function f to 0 already gives me the zeros that we found earlier. Okay? 1, -2, -3, and this will produce a -4. Okay? And there we are done. Okay? We have found the 4 zeros of f of x. And then just concluding here, which of the two outcomes actually was true for f of x? It was this one here. Okay? You had one number that was positive and real, that was 1 itself. And then you had 3 negative real zeros. And these are your 3 negative real zeros. All right, hope that helps.